Hello everyone, welcome to the Math Tutor channel, and we are still looking at some A-level mechanics, both physics and math, and we are going to solve this question. And let's go straight away to business. Don't forget to subscribe, watch, like, and also share with your friends, since it is always lonely at the top. Alright, let's go. The diagram shows a ring of mass 0.1 kilogram threaded to a fixed horizontal rod. Okay, the rod is rough, okay, and the coefficient of friction between the ring and the rod is 0.8. The force of magnitude T newtons acts on the ring in the direction of 30 degrees to the rod. Downwards in the vertical plane contains the rod. Okay, initially the ring is at rest. Okay, so there's a lot of details to consider. Now at rest implies that upward forces are equal to downward forces. Okay, so the fact that there is coefficient of friction, it means that there is friction, because they even mentioned that where the ring is rough, so that means there is friction. Okay, so let's start. They want us to find the greatest value of T for which the ring remains at rest. Whoa, this is really interesting. Okay, so for any object or a particle to stay at rest, upward forces must be equal to downward forces. So we are going to equate the two types of forces, upward, downward, and also horizontal. Okay, we can say left is equal to right. Okay, so this makes the object not to be moving or to stay at rest. Alright, let's go. So looking at our picture, the ring has a mass of 0.1, so that means the force downwards is 0.1 g, but also the horizontal rod has a reaction force which is labeled R. Alright, so let's start with the upward forces. So R is the upward force, R is equal to the downward forces. So when we resolve T vertically, it will be T sine 30, okay, that is that, and then plus there is already another force downwards, 0.1 g. Okay, now coming to the horizontal, there is friction. Okay, so if the tension, the component of tension that is acting horizontally is 2 cos, and it is acting in that direction, that means friction is in the opposite direction, and the formula for friction is given by mu r. Okay, mu is the coefficient of friction, so we can say that friction is equal to mu r. Okay, so the friction force on the left, okay, we can, to make it easier, we can say mu r, okay, is equal to T cos 30. Okay, so we have equation 1, and then we have equation 2. So we are going to use these two equations to find the value of T, which will be really interesting. Alright, so let's go. So mu r, mu is 0.8. Okay, mu is the coefficient of friction, 0.8, and r, we already have our r is T sine 30, okay, plus 0.1 g, okay, and we equate it to T cos 30. Alright, so now we just have to make T the subject, so we can now have 0.8 T sine 30 plus, okay, when we multiply 0.1 by 0.8, 0.1 times 0.8, we get 0.08, so we have 0.08 g equals t cos 30. Alright, so we are going to take all the t's on one side of the equal sign. So we have 0.8 t sine 30 minus t cos 30 is equal to minus 0.08 g. Okay, taking t common, let's continue. So taking t common, just a minute. So t common to be 0.8 sine 30 minus cos 30, okay, is equal to negative 0.08 g. Okay, so let's find out, let's simplify the brackets and we get rid of that. So we start with the left. So sine 30 is 0.5 times 0.8, so this part has 0.4, and cos 30 is 0.866. okay, yes, so we're just simplifying to get t. Alright, so when you subtract bracket, we are getting 0.466. This should be a negative. Okay, so we divide by negative 0.466, divide by, this is 0.08 times 10, remember the g is 10, all over negative 0.466. Alright, so 0.08 times 10 is 0.8, so when we divide it with 0.466, we get our beautiful answer. And so this cancels out, so t will be, and this becomes a positive, so g will be 1.72 newtons, because tension is a force. So this here is the answer to 3 significant figures, and that is the first part, finding t. Alright, I hope you understand. Okay, let's continue to the second part here. Okay, they are asking us to find the acceleration when t is equal to 3. Alright, so we have already resolved the equations. So we know that r is equal to, from our from our previous question, r was t sine 30 plus 0.1 g. Alright, so since we know that, we can put in the t that they have given us. So 3 sine 30 plus 0.1 times 10. So what is r? And what is r here? Checking on the calculator. So we know that sine 30 is 0.5 times 3, 1.5, so we have 1.5 here, and this is plus 1, because 0.1 times 10 is 1, so plus 1, so our r gives us 2.5 newtons. Okay, we shall just use that. We also have another equation, mu r is equal to, what was that? Mu r is equal to t cos 30. Okay, mu r is equal to t cos 30, but remember, reaction is a force, reaction force, and this here is also a force, okay, and that is also a force. Yeah, so we have to get the resultant force between, I beg your pardon, just a minute, I need to check the question again. Okay, they want the acceleration, excellent, so just a minute, we are going to redo this part. Acceleration means motion, it is moving, I beg your pardon, it is moving, but it is not going to move, it's not going to move in the vertical plane, beg your pardon, it is going to move in the horizontal plane. So one of these forces must be causing the motion in the horizontal direction, not vertical direction. Alright, so sorry for that. So now we are going to say we already have R is equal to just a quick one, T okay, we are just going to consider the horizontal forces. So it was T cos 30 is equal to friction force mu R. Okay, so T is 3 cos 30. Okay, and then mu is 0.8 and R was, what was R? Do you still remember? It was, R was T sine, R was T sine 30 plus 0.1 G. Okay, so instead of T we put 3 sine 30 plus 0.1 G. Okay, yeah, now we have got it. We have got the correct version. So subtracting the two, because if you equate the two, that means that the ring is not going to be moving, but they want it to accelerate, so we have to get the resultant of the two. So we shall say 3, so from F is equal to MA, so 3 cos theta minus 0.8 into 3 into 3 sine 30 plus 0.1 G is equal to the mass of the ring was 0.1 and times A. This is the A that we want. So dividing immediately by 0.1 on both sides. So A is, we just have to simplify that. Remember the angle is 30. So shouldn't stress you, that is 30. Okay, so get to the calculator. So 30 cos, make sure your calculator is in the deg mode please, times 3, we have 2.598 minus, okay, minus, we go to the other bracket, so we have 30 sine times 3 plus 1. Okay, so this part here is, this part here is 2.5, then we multiply it by 0.8, so 2.5 times 0.8 will give us 2, so we have 2 there. Okay, then all over 0.1. Okay, so 2.598, sorry, minus 2 divided by 0.1. So we get our acceleration as 5.98. Don't forget the unit. Yes, so this here is the answer to this question. I hope you understood and the attitude towards math mechanics is improving. See you in my next video. Share, like and subscribe. Bye bye.